In this video, we'll talk about stepper motors. Stepper motors are kind of specialty motors, so they are not like motors that is often used just for doing some mechanical work actually. So, for example, often motors like we use for pumps and like say in printers like to do something, but like in printers we also use stepper motors because we have to make like very precise movements. So but like there are some motors like that are like that just like spins actually, so that's it, like you can't really precisely control them. But stepper motors are like very special and like they can be precisely controlled, and this is what is inside the kit motor that you have in your kit. So it is a 4-pole motor. So in any motor you will have what is called a stator, which is stationary, and a rotor, like which will be rotating. And here in this case you will have winding. So as soon as you wind a ferromagnetic metal, it becomes a magnet. So here you are essentially having 4 electromagnets, and by applying a pulse, then like we kind of attract or repel the cogged wheel in the middle, like the wheel is the rotor. So we have that, like, and as we change the sequence of the pulse, or if we change the frequency of the pulse or change the number of pulse, then the step size kind of increases, or we can change the direction, we can change the speed, or we can change the step size, and we can precisely control the stepper motors. And this motor is a geared motor, so the gear ratio is like 64:1, and again, like this will you can kind of like feel this if you try to spin the rotor like with your hands. Actually, you can kind of feel the resistance of the gears. So here, this is the driver we'll be using. This is a motor driver. So this is very simple driver. Like here, we don't have to do much because the power that is provided with the Arduino will be like really less. Like we are connecting an external power supply. In this case, I am using a barrel connector and then connecting a 5-volt power supply to the Arduino board. So I will be drawing power from Arduino, and hopefully when you connect this through the USB, so USB should be sufficient to drive this motor. If I wouldn't run it for too long though. If the current that is consumed by the motor is like really high, then like you will have some heating issues. Like I don't want you to get into that. So what I will suggest you is, like, for the assignment, just run the motor for like say 5 seconds, 10 seconds max, and then like stop it and remove the motor. I wouldn't run it like any longer than that, just to make sure that like your computer USB cable is like not overloaded. But still, like most computers like do it would either disconnect your USB if you draw too much power, or like it'll give you a warning, but I don't want you to get into that. So you can use the power from the USB, that should be sufficient. And here this IC it just has like 7 Darlington pairs. So when we say Darlington pair, it is like 2 resistors connected together in a specific fashion. I believe like we talked about this in module 2. Right, yeah, module 2. And here we are just like using 4 of those. Because like we just have like 4 electromagnets. So those 4 electromagnets are provided with the pulse with this control input. And here we have some LEDs to indicate like what kind of pulses we are sending. So that is the IC. So here is the circuit. I'm going to show you the connection which I've already made. So I have so here is the power supply. I've drawn that. Again, as I said, like I'm using a barrel connector, and then like say I'm providing this board with additional 5 volts, and this should give more power, so that should be okay. If you're just using a USB cable, I wouldn't run it for too long. So here I have connected pin 8, 9, 10, 11. I will also bring the sketch in. So here is the sketch. I will show that here. So here's the sketch. So I'm connecting 8, 9, 10, 11 to 1, 2, 3, 4 in a sequence. So what I'm gonna do is run this. So it's not bad. I will upload it. So the speed is set to 0, so I don't expect anything. You can also observe like what is going to happen here in the LEDs. So let me set the speed to 1 and see what happens. So it's running. It's very slow though. You can see the sequence, like how it works. So now I'm going to increase the speed to maybe 5. Let's see what happens. Upload. It's a little faster. I'm not sure like whether you can see this moving, or you have to take. I'm not sure. Look, the highlights are blown. Maybe we'll see if I could change. Can you see the rotation? Yeah, I think now you can see that. So it is changing its direction. So I'm going to increase the speed even further. Let's see what happens. So I'm going to do 15. And it uses a function which is built in called separ.h. So you don't have to install any additional libraries. So it is like a little bit faster now. I hope you can see that. Maybe I will connect something to that. Okay. So now I think it'll be obvious, like say it is spinning. Okay. So this is how you control a stepper motor. So let's get into the next slide, and like you will be executing, doing an assignment and doing this sequence. So clockwise you will have to run it for 2 seconds and then stop for 2 seconds, counterclockwise 3 seconds, stop for 1 second, and clockwise 1 second. So you will do this sequence over and over. So you will do this code and then you will post that code and you will verify your results with the stopwatch. The most important thing is to run each code, you need some time as well to execute. There's something called overhead time, because like when you write a program, when you use delay, again, it'll be in microseconds. I know that. It might not have an effect, but sometimes it does may have an effect. So you will have to adjust accordingly. So when I say 2 seconds, it has to. If you're using a video, I would use a stopwatch and check, okay, whether it is running for 2 seconds. So the delay has to be adjusted accordingly. So instead of 2 seconds, if it was like say 1.98 seconds, then you will have to make that adjustment in the delay, and then you will have to change it. So so ultimately, like you might because it is in seconds, sometimes you may not have to be like you might not have to have any adjustments, because running a code like doesn't take much time. But like still, I would like you to use the stopwatch and see whether it is exactly spinning for that time period, and then if it is not, you just make an adjustment. So this would be useful later when you're doing some projects where you will have to make precise movements. Okay, so that is question 3.14, assignment 3. So let's see in the next video, which will be the last video of this module and this entire course. And following that, like I'll be uploading some videos, but like that is not going to be included in your final assessment. We'll be talking about GPS and things, but don't worry about that. But whatever is covered until the next video, which is going to be an LCD, will be in your final assessment, and whatever we talk after that is not taken into consideration. That is just if you're curious. Okay, so and we'll wind up this video here, and let's see in the next video doing LCD displays. See you there.